Hello friends, welcome to our channel. In this video, we are going to look at problem 3418, maximum amount of money robot can earn. The purpose of this video is the following. First, we are going to solve this problem using DP, using the DP list, and then we are going to simplify the format of coding. So we are going to write a solution again using DP, but we are going to use dictionary. You will see the difference of these two formats, right? So first, let's look at the problem statement. So here we are given a m by n grid. You can understand it as a matrix, right? So a robot starts at the top left corner, and then it want to go to the bottom right corner. So the robot can move either right or downwards at any point in time. So this determines constrains the direction of movement. So the rules are the following. So the grid contains a value cons ij in each cell, right? If this value is greater than or equal to 0, the robot gains that many cons. Otherwise, the robot encounters a robber, and the robot steals the absolute value of this number cons. So the robot has a special ability to neutralize robbers in at most 2 cells on its path, so preventing them from stealing cons in those 2 cells. So here, this provides some extra constraint for this problem. So we want to return the maximum profit of the robot that can gain on the route. So here, if you look at example 1, so the output is 8. And if you look at example 2, the output is 40. So this second one is very easy to digest because all the numbers are positive, right? But for the first one, you need to pay attention to the two neutralizing effect we can use, or the robot can use, right? So with that said, let's also look at constraints. So here, the m and n are the number of rows and number of columns, and m by n and m and n are both in between 1 and 500. So if you count m by n, it's bounded above by 2500, right? So this last one especially tells us that the cons can be negative, right? So here are some hints. So here it lets dpijk denotes the maximum amount of money a robot can earn by starting at this cell and having neutralized key robots. So here I'm going to write a solution, but I'm not going to use exactly this DP interpretation. So here, to give you an idea, what I'm going to use is like this. So I'm going to define dpijk. So here, let me introduce some numbers, right? So here m will be the number of rows, and n will be the number of columns, and the key is 3, because there are 3 possibilities. You don't need to use the effect, you use once or twice, right, for this neutralizing effect, right? So here I'm going to interpret like this. So dpijk is interpreted as the maximum cons the robot can collect with at most key neutralizing operations used. So here, notice the wording at most. So notice that because of this interpretation, so dpijk means that at most key operations, right, but not necessarily to be exactly key operations. So that's actually a subtle difference from this interpretation. So I guess this is especially important. So if you look at some of the coding or solutions, actually their interpretation is like this, right? So not exactly key. So with that said, actually we are ready to do the coding. We can first do some proper initialization and then do the DP update rule and then get the solution first. And then we're going to simplify the format of solution or coding. So let's move forward. I'm going to copy this one. So the MNK, right? Let's see. So here, because you are allowed to use at most two neutralizing effects, right? K is 3, means 0, 1, and 2. So now we can define a DP table. So here the DP table will be 3-dimensional, right? So we're going to do like this. So float, we are going to assign it to be a negative infinity, because we are going to use maximum function in between, right? Float, let's see. See here for some, actually this corresponding to k for this, for k in range 3. So here I'm writing k, but just actually this can be a dummy index. But in order to make it clear, I will write a dummy k here, or IJS, right? For IJL, L in this one, and then for let's see, j in range m, right? And then we are going to do this for I in range m. So this will be our list. So actually, this is not not trivial. You need to write from inner to out. So this is corresponding to the last index k. This corresponding to the second index n, and this corresponding to the first index m. So you can print out that just to have a feeling about this, right? You can see this this format. So now let's look at the DP update rule. First, we want to do some proper initialization. So here, actually, first let's look at DP 0, 0, and 0. So if we do not use any neutralizing effect at the first position, 0, 0, so the cons collected should be this number, right? And then if we use at most one neutralizing effect, so we are going to have DP 0, 0, and 1. So in this case, we need to consider if this guy is positive or not, right? So if it's positive, just keep it positive. Otherwise, we can using one neutralizing effect, right? So similarly, because this is just a one position, 0, 0, right? One cell. So 0, 0, 2 will be the same actually as the maximum of cons and 0. So we're just copy that. So this is the initialization. So now we want to populate all the numbers to the cells of this DP table. So I'm going to write it as DP update. So this is a standard for loop for I in the range m, for j in range m, right? So we also need to iterate over k for k in range 3. So actually here it's better not to use use k, so we can use n options, right? So you can just put it here rather than hard coding it. So we have this one. So now then if I equals 0 and j equals 0, we have already set all the possibilities for k's 0, 1, 2, right? So we just continue. So once we checked this, first let's get the gain. The gain will be cons ij. You don't need to specify this, but I just make it clear, just to don't need to call this number again and again. So now first, if I is greater than 0, this means that we can, to arrive at this position ij, we can from here I minus 1 j to ij, right? So this means downwards. So in this case, first let's update dp I, j, and k. So because we have some initialization, so we should be compare with the original state, right? Then if we do not consider neutralizing effect, what we are going to do is dp I minus 1 j and the k and plus this gain, right? So this is very natural. Now if we consider the neutralization, so if k is greater than 0 and again is less than 0. So in this case, we need to use one more neutralizing effect. So this way we can update this dpij key again. So compared to its previous state, I, j, and the key. And then another one is that we can jump from here, I minus 1 and the j. But we should, if we want to use neutralizing effect at this position, I minus 1 and j, we can use at most k minus 1 neutralizing effect. So that's the state, because we are using neutralizing effect at position ij, so we collect actually 0, right? So if we write like this, that's actually more interpretable. Let's add this 0 here. So this is the one case. In parallel, so we can consider if j is greater than 0, right? So if this is the case, it means that, so we can also from this position to ij, right? It means that we move to, the robot moved towards the right. So in this case, we can also update this dpij key. So again, the same pattern, the previous state, I, j, and k. And then because now you move from I and j minus 1 and k, so you can collect again. This is the one thing. And then also we need to consider if we need to use one more neutralizing effect. So in other words, if k is greater than 0 and gain is less than 0, right? So then what we want to do is dpij k, right? So again, similar pattern. So we need to update compared to previous state. And now, so we can come from I, j minus 1. So we can use a neutralizing effect at the current position. In other words, at the previous state, so we can use at most k minus 1 neutralizing effects. And then we can add, because gain is 0. If we do not use neutralizing effect, we are going to add again. But here we add 0, right? So that's actually the main dp update rule. So now we just need to return. So what we want to return is dp. So if you do not want to pay the detail, it should be this one, right? Let me first do a check. It passes the test case. And now let's look at the generic case. Yeah, it passes all the cases. So now I want to see here, if you want, you can write m minus 1, n minus 1, minus 1, and 2 are the same thing. But here, actually, after finishing this version of solution, we found that, here we have some checks for I is greater than 0 and j is greater than 0. It's very tedious in a sense. So next, we are going to write another solution format. Same idea, but different coding format. I'm going to use a dictionary. So you are going to see that the second solution will be much compact and much shorter, right? So what I'm going to do, I'm going to copy this part. And then I'm going to change this one to be version v1. So here, actually, initializing this dp table 3-dimensional is sort of tedious. I'm going to change this one to be a dictionary. So here, what I'm going to do is I'm going to write a function. You can, so sometimes I interpret like this. So you can do f collections default dictionary, default dict. So I'm going to map everything to be negative infinity first. This is very convenient because currently I didn't specify the key format. So what we are going to use is like this tuple, right? ijk, then map to a number, a maximum coins, right? So because of this, we are using default dictionary. If the key hasn't been in the dictionary yet, so the value, if you retrieve, it will be defaulted as negative infinity. So you will see this actually brings us a lot of advantage. So similarly, initialization. So f, I can write like this now, right? this is just nothing but cons 0, 0. The reason we can write like this is because this is a tuple. You can write like this, right? Or you can ignore the parentheses. For convenience, I'm going to ignore the parentheses, but for readability, you can add it, right? But here, I'm sort of lazy to, so I do not write the code, the parentheses. This just save some typing. So F0, 0, 1, using at most 1 neutralizing effect. So we're going to have this one to be 0. In other words, if this guy is less than 0, we use 0. Same for F0, 0, 2, right? So I can copy this part. But also you can set it as F001. So this is the initialization. Now let's look at the DP update. So similarly for I in range M, for J in range M, and for K in range N options, right? So what we want to do is to check if I equals 0 and J also equals 0. So in this case, we are going to continue, right? Because we already set up these 3 numbers. So now let's look at the DP update rule. So here I don't need to check all those like I and G. I just need essentially one line of code. But let me write it again, cons ij. So now let's look at how to get this f I g key. So at this position ij, we use at most key neutralizing effect. So it would be the pre-state, that's for sure. And then if we start from a pre-position, so we can consider adding the gain, that is fi minus 1 g. So if you want to use the, you already use the up of the key neutralizing effect, and the current cell you do not use the neutralizing effect, you need to add gain, right? So now if you didn't use up and you want to use neutralizing effect at cell ij, so you are going to have I minus 1 g, the key minus 1. So in this case, you are going to add 0, right? So this is for I. But you might wonder, so is I greater than 0? So it does not matter, because if this guy is negative 1, it does not appear in the dictionary. So you are going to contribute to negative infinity, right? It will not contribute much to the max, right? So now let's look at another one. So for J, so that is I and J minus 1 and the key. So if this at this position you already used up all the key neutralizing effects, so you are going to just add this gain. Or if you choose to use one neutralizing effect at here, so you're going to have add this one, right? So this gives us the DP update rule. So now let me delete this 0. So actually adding this 0 is more, more interpretable in a sense. How many terms we have? 1, 2, 3, 4, 5, right? So now what we want to do, we just need to return f. So in this case, you need to write m minus 1, n minus 1, and n operations minus 1, right? So let me do a check. So I have changed this one to be v1. Now we are checking this one. It takes some time. Let's see. Yeah, it passes. So basically what I want to mention at the end is that, so when we use dynamic programming, especially using DP tables or tabulation, so the interpretation of the generic term actually is crucially important. So this interpretation determines 2 things. First, the initialization. Second, the DP update rule. So this is one point I want to make. The second point I want to make is that sometimes if you use dictionary, and then it can bring you a lot of convenience. For example, if you count the lines of code here, and in this first version, you do a lot of checks, IG, right? Of course, it has the advantage that you know very well about the details. And then in the second one, so we just write one line of code for the DP update rule. So this way, actually, it's more compact, it's more a higher level. So this is the second point I want to make. So with that said, I guess that's the end of the current video. Thank you for watching.